Okie dokie. In this problem, they say, according to the empirical rule, what is the probability that z is greater than 0? Assume the data is normally distributed. So the empirical rule is basically this idea. So assuming the data is normally distributed means that we are assuming we have this bell-shaped curve here, where the mean is in the middle. The mean is in the middle, and the z-score will tell us the number of standard deviations away from the mean, left and right. So one standard deviation away from the mean. Basically, the empirical rule tells us like how much percentage or how much of the data is accumulated for, accounted for between -1 standard deviations and +1 standard deviation. So, if you go 1 standard deviation left and right, you are containing 68% of the data, and if you go 2 standard deviations away, you have 95% of the data, and so on. So, that's kind of, so like here, where they ask what's the probability that z is greater than 0, what that means is how much percentage, how much area under this curve is being accounted for all the z values that are greater than 0. For z to equal 0 means that you are at the mean, basically. So like for z to be greater than 0, that means they're asking us how much is shaded to the right of z equals 0. And just by looking at this curve, we can tell that's 50%, right? So our answer will be 50%, but I do want to show you a way to kind of navigate these ideas on Excel just to make it a little bit easier, but I hope just kind of explaining that with this image here makes it make a little bit of sense, especially if we describe something like this with the image here. So what's the probability that z is less than -1? So going on this graph here, what's the probability that z is less than -1 means that this is the z value of -1, right? It's -1 standard deviations. And they're wondering what's the probability, or what's the percentage that is less than -1, meaning shaded to the left of -1. So they're asking what percentage of the area under the curve is shaded right here out of the total 100%. So you could use like empirical rule stuff, like the visual memorization stuff, to find that, or we could use Excel. So that's why I have Excel pulled up. We're just going to do the rest in Excel, but I just wanted to give that visual if you were curious about the backstory, I suppose, the conceptual understanding. Let me grab my keyboard and we'll get started. Let me put this here. All right. So probability that z is less than 1 or -1. We're going to use equals. We're going to use a function in Excel. We're going to do equals Norm.s.dist. Norm.s.dist will return the standard normal distribution. So that's a fancy way of saying we are just going to input the z value, and it's going to actually give us right away the probability that z is less than whatever z value we plug in. So plug in -1 for z. So here they tell us we have to plug in a z and cumulative. So cumulative just means type in a 1. You will type in 1 every time for cumulative, and then you'll just type in your z-score right here every time. So we have Norm.s.dist -1 for the z value, and then 1 every time for the cumulative value. And what this is giving us right away is our answer. So this gives us 0.1586. That would round to, I guess they're just rounding that to 0.16, which is equivalent to 16%. That's option C. We break out the eraser to see that C is our answer. So what I want to kind of categorize is this. When you're finding z is less than some value a, probability that z is less than a, you're going to use equals Norm.s.dist with that z-score, so that a value, comma 1, every single time. That'll get you that. Sometimes they're going to mix it up. Z greater than a, for example. Now keep in mind, Norm.s.dist only gives you the probability where z is less than that a value. So for z is greater than the a value, what we have to do is 1 minus. So I guess I'll do equals, this is what you type into Excel, equals 1 minus Norm.s.dist of a, comma 1. So we need that 1 minus to give us the z greater than the A value. Okay. Now the mamma jamma, we'll talk about it when we get there, is sometimes they'll give you two values. So like A is less than or equal to Z is less than or equal to B. So the Z-scores, the probability between two Z-scores basically. And so I guess I'm going to go ahead and do it here actually. Let's just do equals Norm.s.dist of A, comma 1. Sorry, let me do that backwards. B, comma 1. You find the first one, or the second one first, and then you subtract Norm.s.dist of the A, comma 1. Need more space, of course. Let's try that again. Norm.s.dist A, comma 1. Probably could have made this key before I made this video, but you know, a key is very helpful. Okay, there's a key. Let's do 3 more problems using that key. So here they say, according to the empirical rule, what's the probability that P is between, or sorry, the probability that Z is between 1 and 3. So I'm going to demonstrate this. We're going to do equals. We're going to do the Norm.s.dist with the upper bound, the 3, always comma 1, and then we're subtracting Norm.s.dist for 1, that's our Z-score, and then comma 1. So this will give us the probability between a Z-score of 1 and 3. We get about 15.73. 15.73, let's hold this up. We're just going to pick the closest to that answer. So 15.73%, which is option D here, 15.85. So it's kind of just a matter of rounding, whether you're using certain tables versus like exact values. I think the 15.7 is a more like exact value. This is like a, you know, kind of rounded sort of value. Anyway, let's do 2 more. So -2 and -1. We can just change these values since we have it set up kind of like, you know, in the same format from the last one. So we use the upper bound, the -1 first. That's our first Z-score that we'll type in. And then our lower bound, -2, will go here. Hit enter, and we get 13.59, 13.59%, which is option C. About 13.5-ish. Always pick the closest answer. You get the idea. Let's do one more. All right. Probability that Z is less than -3. So for any less thans, all we have to do is the regular old Norm.s.dist. Okay, so for Z less than -3, we'll just change the Z value up here to a -3, and it's still always comma 1. So a very small percentage for this one. If we make this a percentage from a decimal, it'll be 0.135%. Okay, 0.135 is closest to 0.15%, and we are done. So hopefully this gave you enough ammo for approaching this question. Again, this is sort of the key right here. Hope that helps the most. And hopefully the explanation at the beginning helps with understanding like what we were actually finding each time we were doing this here. Hope that makes some sense. If you have any questions about this though, please let me know. All right.